So these are some whiteboards for ILBSin Theta. So our first one here is a 0.15 Tesla magnetic field is 27 degrees east of north. What's the force on a 3.2 meter long wire if the current is 5 amps to the west? Oh, good God. Great Scott. So let's draw the picture. The magnetic field is 27 degrees east of north. So here is north and south and east and west. And the magnetic field is 27 degrees. Yes? Okay, so that is a 27-degree angle. The force on a 3.2 meter long wire if the current is 5 amps to the west. So let's draw the current. And it's 5 amps. Yeah? And the magnetic field is 0.15 Teslas. Yeah? And this wire is somehow 3.2 meters long. Now, I'm trying to sucker you into using the wrong angle. Is 27 degrees the angle between B and I? No, it's not. It must be 117, yes? So this angle here, right? And that's of course, this is, one of the many problems that we'll have on the skill set. This will be number 1, for example, right? Where I try to sucker you into using the wrong angle. You have to draw the picture, right? You have to understand what east of north means, 27 degrees east of north. That's what that means, right? Does that make sense? Right? And then you have to draw the picture, then you have to figure out that the angle really is 117. Does that matter? 27. Yeah, it does matter. It matters. I know that an angle and its supplement have the same sign, don't they? I believe so. Is that right? An angle and its supplement have the same sign. My calculator knows. Let's try 63, sine of 63. Let's try the sine of 180 minus 63. Indeed, it is true. Yeah, because of the unit circle thing. I was a bad student, so I didn't. Yeah, you got it. Yeah, but we're using down to mean that. But yeah, you're right. Into the page I would accept. Yeah. We're doing whiteboards, and the trick with this whiteboard is that the angle is the angle I give you is not the tail-to-tail angle, so you have to be careful. That's right. How do we know it's down? You guys seem very confident. Index finger this way. Oh yeah, it would be, yeah. Because you can't do this with your finger, right? So it's going to be. I'm going to break my finger. Ah! Oh yeah, it's down. You guys ever do that? That's right, yeah. Do you ever stick like a carrot in your mouth and then go, this finger and then you snap the carrot? Yeah. It's not that funny.
No, I can't see that.
Or here's another really funny thing, is you stick a piece of carrot in your, right, in your hand like that, and you go, look at my thumb, and then just go. And celery is even better because celery goes kind of, right? It's really good. Yeah, wherever there's celery sticks, I go, listen to this joint. Does this sound right? And it makes kind of a gristly crunch. If you add a carrot to it, there's like a crunch and then a pop. Like that, yeah.
Put a lot of thought into this. Gotta do what you gotta do.
Yeah. There we have it. Is everybody done? Are we plugged in numbers? Yeah. So this one's going to be ILB sine theta, right? So it's going to be 5 amps times 3.2 meters times 0.15 Teslas times sine of 117. Is that what, was it 117? Is that what it is? Is that the right way to do it? Yeah? And if you do the same thing with a sine of 27, you get the wrong answer. So, yeah, there we have it. Are we ready for the next one? What current, in what direction would you need to have a 10 Newton force of 10 newtons to the west in 50 centimeters of wire perpendicular to Earth's magnetic field of 0.5 times 10 to the minus 4th Teslas to the north? So yeah, Earth's magnetic field is there, but it's not really all that strong, right? So again, let's draw our picture here. We've got force to the west, so north, south, east, west. Our force is to the west. Yeah, 10 newtons. Apparently we have 3 sig figs, right? 50 centimeters of wire, so 0.50 meters. And the force is 10.0 newtons, right? So we need to know the current, right? And the magnetic field is 0.5 times 10 to the minus 4th, right? And then what is the angle between, so here's our magnetic field. What's the angle between north and west? 90 degrees. Sine of 90 is, so when they're perpendicular, sine of 90 is 1, if you're in degrees. If you're in radians, it's, here we have it, right? So now you're just solving for I. What current? See, thumb is this way. Magnetic field is that way. Which way is the current flowing? Directly upward? Yeah, there we have it. Yeah, it's got a lot of amps in it. 10 to the 5th. 1, 2, 4 times 10 to the 5th. Yeah, you got it. Yeah. How many zeros does that have? Is that 5? I love that. It's got 5 zeros. I love it. There you go. How would you write this? Oh, we only have 1 sig fig because of the Earth's magnetic field, right? So with 1 sig fig, you would write this 4 times 10 to the 5th amps. Is that a lot of current? It's a lot for your iPod. Yeah, it's kind of a lot in general. Yeah. Yeah. Do you know what direction? Yeah. Let's do the direction all at once. Can everybody get out their right hand? Their right hand. Okay. The force is to the west, so the thumb must be to the west. Magnetic field has to be toward north. It hurts us. Yeah? Thumb is this way. Magnetic field is that way. Which way is my finger? Yeah, out of the page. Which out of the page is up, interpreted on that. Yeah? Are we ready for the next one? I'm ready for it. 17 centimeters of wire forms a 37-degree angle with an unknown magnetic field. And here we don't even know the direction, so we assume that they measure the angle correctly, that it's tail to tail, which it sounds like it, right? So 37 is the angle we'll use.